Welcome to Brain Vision.
Here, in this problem, as the cone surface is frictionless, so there is no net force on the system during the firing of the rifle. And as a result, the total momentum of the system is same before and after the rifle is fired. So here we take positive x axis to be the direction the rifle is aimed. Now, initially, both the hunter and bullet are at rest. So initial momentum is equal to 0. Now we have given here mass of bullet equal to 4.2 gram. Now we just convert this into kg. Therefore, 4.2 multiplied by 10 to the power minus 3 kg. Also, we have velocity of bullet equal to 965 meter per second and mass of hunter including his gun equal to 72.5 kg. Now we have to calculate the recoil velocity of the hunter when rifle fired horizontally. So for that we have to find out the momentum of bullet when the hunter fires the rifle horizontally. So momentum of bullet can be expressed as P equal to M multiplied by V naught. Now here small m represents the mass of the bullet and V naught is the velocity of the bullet. Therefore, we get P equal to 4.2 multiplied by 10 to the power minus 3 multiplied by 965. So P equals to 4.053 kilogram meter per second. Now, since the net force on the system is 0, as we discussed earlier, so the total momentum of the system is same before and after the rifle is fired. Thus, momentum of hunter is equal to 4.053 kilogram meter per second. Now, from the law of conservation of momentum, mv plus mv naught equal to 0. Now here v is actually the recoil velocity of the hunter. Capital M is the mass of the hunter with gun, and small m is the mass of the bullet, whereas v naught is the velocity of the bullet. Now let's rewrite this for v. Therefore v equals to minus mv naught divided by capital M. So we get v equal to minus. Now this is the momentum. Therefore we can substitute here 4.053 for mv naught divided by 72.5 kg. Now this is actually the mass of the hunter with the gun. So from above we get v equal to minus 0.0559 meter per second. So here this negative sign actually shows the recoil velocity. So the recoil velocity of the hunter when rifle fired horizontally is 0.0559 meter per second. Now comes to part B. When the hunter fires the rifle at 56 degrees above the horizontal. Now here velocity of a bullet along horizontal direction is given by V1 equal to V naught cos 56 degree. Therefore, V1 equals to 965 multiplied by cos 56 degree. So from above we get V1 equals to 539.62 meter per second. Now, momentum of a bullet along horizontal direction V1 equals to m multiplied by V1. Now substitute the values. We get P1 equals to 4.2 multiplied by 10 to the power minus 3 multiplied by 539.62. So from above we get P1 equals to 2.2664 kilogram meter per second. Now we have to calculate the recoil velocity of the hunter when rifle fires 56 degrees above the horizontal. So for this, since the momentum of a hunter is equal to the momentum of a bullet along horizontal direction, that means m v dash equals to 2.2664 kilogram meter per second. Now here v dash is actually the recoil velocity of the hunter. Now from the law of conservation of momentum, we have mv dash plus mv1 equals to 0. Now from above we get v dash equals to minus mv1 divided by m. We get v dash equals to minus 2.2664 divided by 72.5. So after dividing this, we get v dash equals to minus 0.0313 meter per second. Hence, the recoil velocity of the hunter when rifle fires 56 degrees above the horizontal equals to 0.0313 meter per second.